Hey, hello. Today we have assignment, actually it should be March 31st, right? Let me type that in. And it's about comparing linear, quadratic, and exponential models. So really quickly, you've had, in the first trimester, we spent a lot of time determining a model that would fit data that has a linear pattern. Now what we want to do is, as you know, we've been studying exponential data with an exponential pattern and we will eventually be studying data that has a quadratic pattern. So what I'm going to do is I'm going to give you the notes to be able to answer the first few, the notes that you'll need to be able to do this assignment. And then after that, you'll have an assignment with several questions. There's only 9 questions on it today. We're also going to talk about domain and range as well. So the first thing is this. I've got some notes here. Let me make them bigger. So the first thing you'll notice is if you get a scatter plot and you take your pencil, for example, let me do this real quick. But yeah, so if we look at this first one here, right? And you see the data here, it kind of goes, if I was to make a point that goes through it, it makes pretty much a straight line. So the best one for that would be like a linear pattern. Okay, so let me go ahead and look at the notes. So the notes is a straight line. And the shape would either be increasing or decreasing. And here's the equation form. So go ahead and put this in your notes. This is the generic form, y equals mx plus b. An example of it would be y equals 2x plus 10. Now the domain represents all the different possible values that are on the data set that we have. Here, as you can see, it starts, and so we look at the x values or the horizontal values, and it starts at 5, so it would be 5 is 2 to what? It goes up to 10, okay? So then that means that that would be the domain. And it's also considered the independent variable. Now the range is all the values vertically going up measured on the y-axis. So that's called the dependent variable. And the range here is a minimum is, I go to this scale, it's 2 to the maximum over here to that scale, 14. Okay, real life example might be hourly earnings. Basically, you get the same amount extra every extra hour you work, so it's a constant rate. Every hour, maybe it's $20. Work another hour, $20, etc. So the point is, it would, if you were to plot your check, for example, based upon how many hours you work, so every extra hour you work, it would be go up by the same amount, by $20, by $20, and that would look like a linear function if we graphed it. Okay, so that is a linear one. The next thing is a quadratic one. The thing that you'll notice about quadratic of these three, it's the only one that changes direction. It starts here, it goes kind of up for a while, and then it goes down. It could also go down and back up again. So we call that a parabola. It's curved, it has 2 directions, up and down or down and up. The generic form is this right here. So if you want to put that in your notes, and then here's an example of it. What you'll notice about it, it's got x and then it's squared, whereas the linear doesn't have any exponents. It's just some number, m in this case, a slope multiplied by x, and b would be the y-intercept. Here, you've got a squaring aspect to it, as well as, in some cases, a non-squaring. And you also have a y-intercept, which would be the c. Okay, the domains, just like before, if you understood the domain and range before, it's what's the minimum point is from 8 to the minimum point here, 13. The range is 29, minimum. Oh, by the way, this is the tricky part. So the minimum, you might say, well, hey, this is the minimum, right? But no, it isn't, because it looks about 40-ish or so. The minimum is actually lowered over here. So this looks to be about, I guesstimated it, as long as you're guesstimating closely, it's between 20 and 30, close to 30. So I just put 29. And the maximum, same thing. I'm not exactly sure. It's kind of lower 50s. So I put 29 to 52. Examples. A ball in the air would be model. It goes up and then comes down. Temperature would be another good real life example. In the morning, it's cooler, it gets warmer, and then starts going down after sunset. So that would be another one. Okay, so that's how you can tell if something is quadratic, goes up and down or down and up. And finally, this is kind of what we're studying this unit. Is if you get a graph here that it curves, it gets steeper and steeper, or it could get lower and lower, right? There's two options. Either it starts and gets steeper and steeper, or it could start like this, like a decay situation, and go down and get flatter and flatter. The point is, it only goes, it's curved, and the steepness changes, unlike a line, a linear one, and it only is in one direction. Either goes all down or all up, okay? One direction, but it's curved. Here is a form, and we've been learning about this so far, where it is a to the a, which is your starting point, if you remember, and then it's got a growth factor or decay factor, and here it's got an exponent, but the exponent is the independent variable. It's a variable, right? So for example, here we have an exponent when it's quadratic that's always 2. It's always squared. There's some part of the formula that's squared, the equation that's squared. Here it it's not squared, but it's also a variable in the exponent. In this case, I just put x. It could be some other letter like t for time, etc. Okay. Domain the same. Starts in this case starts at 10, goes to 15. That's the x values. Range starts. I just estimated about 2, goes up to the highest point a little bit over 30. Some real life examples we're going to be studying pretty soon are investments that grow at a percent increase, percent growth, and disease growth, or decay. Like radioactive decay would be something that starts up here and gets less and less. So use that to go ahead and now you can answer the rest of the questions on the assignment. You should be able to look at that and tell what it is. Same with those. The equations, you should be able to look at the structure of the equations to tell. And finally, you've got domain and range for the various ones. So that is the assignment for today, and that will help you as we start to model actual data moving forward. Okay, so make sure you answer it and enter your answers into Canvas.